All right, welcome back. In the last lesson, I introduced you to interfaces. In this lesson, we're going to practice working with them in a practical way by building onto the MoneyCard program and its subclasses that we created in the previous Java 201 course. Now remember that you should have already watched the previous Intro to CS Programming with Java courses before proceeding with this one. So if you're unfamiliar with the MoneyCard program and its subclasses, I'd encourage you to work through those courses beforehand, as this lesson is going to build onto that, and it's going to be pretty complex, at least compared to what has been covered in the previous courses. Now let's briefly take a look at our MoneyCard superclass and the other subclasses to get a refresher of what's going on here. Let's start with the MoneyCard superclass. And this class just acts as the template or the mold that our subclass will be modeled after. We have our balance instance variable, and then a few methods here that would be common to all subclasses, such as getting the balance and making a purchase. Then we have our gift card subclass, which extends the MoneyCard superclass, and it just sets up its constructor here to create a new gift card with a new balance that can be passed in when the object is created. This subclass doesn't add or change any functionality of how a MoneyCard would be used. It's just simply extending the MoneyCard class to inherit its properties and methods. Next, we have our debit card subclass, which also extends the MoneyCard class. And here we set up our constructor. And additionally, we give this subclass a new deposit method to handle depositing more money back onto our card. And lastly, we have our credit card subclass, which also extends the MoneyCard superclass, but the credit card subclass differs from the other subclasses in that the balance of a credit card is how much you owe, whereas in a debit card and a gift card, the balance is how much you have to spend. So in our constructor for the credit card, we set the balance to 0, since you don't usually owe anything on your credit card when it's first opened. Now for the credit card, we also needed to create a new instance variable to hold the card's credit limit so that we know how much we can spend. And we set that credit limit by passing in the amount as a parameter to our constructor. We also had to override the makePurchase method of our MoneyCard superclass. That is, we gave this method new instructions that are different than the instructions of the original method so that it works properly for credit cards. And then finally, we added a couple of new methods that are specific to credit cards to make a payment and get the available credit. All right, now that we've been refreshed on how our MoneyCard program works, let's add in some new functionality to handle the acceptability behavior of our money cards. So depending on the type of money card, the location of where the card may be accepted at can vary. Usually credit card and debit cards are accepted everywhere. They're accepted at almost all locations, whereas a gift card is only accepted at select locations. Now we could go into our MoneyCard class, and we could write a new method inside of our MoneyCard superclass here, which would return back an acceptability location. And then inside of all of our subclasses, like the credit card or debit card class, we could override that method since it's going to inherit it from the MoneyCard superclass. So we could override it inside of each of our subclasses and have this print out a new location or a new acceptability location for each type of card. But this could get pretty tedious because each time that you would create a new subclass, you'd have to override the method. And it can even become quite a maintenance nightmare if you had a lot of different types of MoneyCard subclasses that shared a similar implementation. If you decided to make a change to them, you'd have to go through each subclass and make that change multiple times. You also end up with a lot of duplicate code spread out among our subclasses. Instead of creating this big mess of a problem with overriding our methods, we can solve this by extracting out this common functionality by moving the method for the acceptability behavior into an interface. We'll then create separate behavior classes that will implement this interface and give the method its own individual implementation. This means that the code can be reused within our MoneyCard program. Essentially, our subclasses can use the appropriate behavior classes which implement our interface depending on what they need to do. So let's start by creating a new interface. You can hit Command-N or Control-N on Windows. We'll just type in interface here and select interface and hit next. And we're going to make sure to store this into our inheritance and poly package, as that's where the money card program is at. And I'm going to give this a name of acceptability, and we'll just hit finish. There we go, and here's our interface. So you can see that this looks pretty much just like a class, except that it uses the interface keyword instead. Now inside of our interface, we can define a method for the acceptability behavior. We start with its access specifier of public. We'll give it a return type. I'm going to set mine to return a string, and then we'll just give it a name. I'm going to name mine location, and then we'll open up our parentheses for our parameters, and I'm just going to leave them blank, as this method doesn't need any parameters, and we'll end the statement with a semicolon. So what we've created here is an abstract method. It's just the method definition without an implementation. That is, it has no instructions. Now to use our interface, we need to create a class which will implement the interface and give this method an implementation. So we can make multiple classes that handle different acceptability behaviors, and each one can give this location method its own specific implementation. Now this location method will be used to return back a different accepted at location, depending on the type of money card. Some money cards, such as credit card and debit cards, may be accepted everywhere, at almost any location. So we'll need one class for that behavior. And other money cards, such as our gift card, may be only accepted at very specific locations. So we'll need a second class for that behavior. So let's create a new class. And we're going to store this into our inheritance and poly package. And I'm going to give this a name of accepted everywhere. That's with a capital A and a capital E. And we don't need the main method, so make sure that all of these checkboxes here are unchecked, and we'll hit finish. Let's now have this class implement our interface. So right after the class name, accepted everywhere, but before the opening curly bracket, we use the implements keyword, followed by the name of the interface. In this case, it's our acceptability interface. Now, if you notice, we have an error here, and if you hover over it, you can see that it's complaining about us not yet implementing our location abstract method from our acceptability interface. So anytime you have a class implement an interface, you must give that interface's methods an implementation. So inside of our accepted everywhere class, let's create the location method. We start with its public access specifier, its string return type, and its name of location. And now we can give it an implementation. We're just going to keep this really simple. So this is just going to return a string which says acceptable at all locations. And we now have this behavior of getting the acceptability of a money card that's accepted anywhere. We've extracted it out into its own class, and it's not being duplicated across our subclasses. We'll be able to reuse this from within our credit card and debit card subclasses, or any other subclasses that we may create. Let's now go ahead and create the other class that we need for the acceptability of a gift card. I'm going to create another class, and I'm going to give this one a name of accepted select locations. That's with a capital A, a capital S, and a capital L. And we don't need the main method, so we'll make sure that all of these boxes are unchecked, and we'll hit finish. And again, let's have this implement our acceptability interface. So we use the implements keyword followed by the interface's name, acceptability. And then inside of our class, let's create our location method. We start with its public access specifier, its string return type, and its name of location. And let's give it an implementation. This one's also going to return a string, and this one's just going to say acceptable only at select locations. All right, we have our two classes which implement our interface to handle the two different behaviors of money cards being accepted everywhere and money cards being accepted at only select locations. So you should be thinking of these two classes as two separate behaviors, and our money card subclasses will now be able to use these behaviors as needed. Now we just need to integrate these into our money card program. So let's start in the money card superclass. Looks like it's hidden here. I have too many files open, so I'm going to select money card. Now, all of our money cards are going to need to access the card's acceptability behavior, but that behavior may differ depending on the subclass. Remember, we have the Accepted Everywhere class for the credit card and debit cards behavior, and we have the Accepted Select Locations class for the gift card behavior. So we can do this by creating a new instance variable of the same type as our interface here inside of our money card superclass, which all of our subclasses will inherit. And this instance variable is going to be able to hold a reference to one of the behavior classes that we just created. Now, if you're feeling confused, don't worry. This will make much more sense once we have it working. So inside of our money card superclass, let's add in a new instance variable. We'll give it a protected access specifier. We're going to give it a type of acceptability, just like our interface. And then I'm also going to give it a name of acceptability as well. Now, since this instance variable is of the type acceptability, it can hold a reference to an object of any class that implements our acceptability interface. This means that this instance variable could hold a new object of the Accepted Everywhere class, or it could hold a new object of the Accepted Select Locations class, or any other class that may implement our acceptability interface. So we'll have access to this instance variable, which will be an object, and we'll be able to call its location method to get the money card's acceptability location. We now need a method that we can call to use this acceptability object and call its location method to get the location that the money card is accepted at. We'll create that method here inside of our superclass. That way all of our subclasses will inherit it. And since we're using an interface, we won't have to duplicate this across all of our subclasses. So at the bottom of the class, I'm going to create a new method. I'll give it a public access specifier. It's going to be returning a string, and I'm going to give it a name of getAcceptability using camel case. Now inside of here, we can use our acceptability instance variable that we just created, and remember that it is an object of a class that implements our acceptability interface. In this case, it could be an Accepted Everywhere object, or it could be an Accepted Select Locations object. The exact object that it holds a reference to doesn't matter though, because we know that any class which implements our acceptability interface will also have that location method. So we can call that location method to get the location of where the money card is acceptable at. We'll then just make sure to return this using the return statement at the beginning. And that's it for the method. So let me go over this one more time just to make sure you understand it. Our acceptability instance variable here at the top is of the same type as our acceptability interface. That means that our instance variable can hold a reference to an object of any class that implements our acceptability interface. We then have a method which we named getAcceptability, which we use to call our acceptability object's location method. Now, depending on the object that our acceptability instance variable is holding, that location method will return different results. If the acceptability instance variable is set to hold a reference to an Accepted Everywhere object, it'll say that the card is acceptable at all locations. On the other hand, if the instance variable is set to hold a reference to an Accepted Select Locations object, it'll say that it's only acceptable at select locations. So this will allow us to set the behavior for our subclasses from within the subclass's constructor, simply by setting this acceptability instance variable to hold a new object of one of our behavior classes, like the Accepted Everywhere class or the Accepted Select Locations class, or any other class that you would create. So let's do that next. Let's go into the credit card class, and inside of the constructor, we want credit cards to have the Accepted Everywhere behavior. So we can set the acceptability instance variable to hold a value of a new Accepted Everywhere object. And now when a new credit card is constructed, it'll set it to use our Accepted Everywhere behavior. It'll then set the balance and then the credit limit. Then when we call our credit card object's getAcceptability method that it inherited from our money card superclass, this acceptability object is going to know that it's an object of the Accepted Everywhere class, and it'll call that class's location method returning back the string saying that the credit card is accepted at all locations. So let me go back into credit card here and save the file real quick. And now let's set up the behaviors for the other subclasses. So let's go into the debit card class. And so for a debit card, this type of card is also accepted everywhere. So we'll again want to set the acceptability instance variable to use the accepted everywhere behavior. So inside of our constructor, let's set the acceptability instance variable to hold a value of a new accepted everywhere object. And we'll save this. And now lastly, let's move into our gift card. And so this one's going to need to use the accepted select locations behavior, since gift cards are only acceptable at select locations. So inside of our constructor, let's set the acceptability instance variable to hold a value of a new accepted select locations object. And that's it. So by placing a common behavior of a money card's acceptability into an interface and then creating specific behavior classes, we don't have to worry about having duplicate code, we don't have to override the method each time we create a new subclass, and our program will be much easier to maintain since we only have to modify one class instead of multiple subclasses if we want to make changes. Let's now test this out inside of our money card tester class. So let's open up money card tester. So let's print out the acceptability for all three of our different money cards here. Here's our first card, it's our gift card class. So right at the bottom, let's just use system.out.println, and we'll use our GC object, and we'll call its getAcceptability method. Now I'm just going to copy this line, and let's paste it down here below the debit card section to print out the debit card's acceptability. And make sure to change this to use the DC object for the debit card. And then lastly, let's just paste it one more time down here for the credit card's acceptability, and make sure to change that to the CC object for the credit card. Make sure to save your file, and let's run the program. And let me just resize the console so that we can read everything. And great, we can see that each class is using the behavior that we set inside of its constructor. We have the gift card being acceptable only at select locations, while both the debit card and the credit cards are acceptable at all locations. So I hope you can see how awesome interfaces are for code reuse. If not for using an interface, we would have had to duplicate the getAcceptability method across all of our subclasses, and each one would have had to be overridden and had its own implementation. And then each time we'd create a new subclass, we'd have to override it in there as well. Also, remember how both our credit card and our debit card classes are both using the same accepted everywhere behavior class. Had this method been duplicated across both classes, and if we ever wanted to make a change to its behavior, we would have had to change both of those classes. Now I know you're thinking that here it's only 2 classes, and that wouldn't be that big of a deal to change. But in larger projects, you may have 20, 50, or 100 classes to make changes to. But since we used an interface and extracted this out into a separate behavior class, we would only need to modify that one accepted everywhere class to make that change, saving us a lot of time. Now I don't want you to think that overriding methods is a bad thing, because it's not. You will need to override methods, but you just don't want it to get out of control to where you're overriding everything in all of your subclasses. If you find yourself doing this, you may want to consider extracting that functionality out into an interface. Now I also know that this is a small example, and you may feel that we jumped through a lot of hoops for something that's pretty simple. But I tried to keep the sample code here as easy as I could, so that you wouldn't get lost and overwhelmed from a larger application. And this allows you to focus on the concept of how to use the interface. But once you start working with larger and more complex projects with more classes, you'll find that interfaces are extremely helpful. Next up, we're going to begin working with different kinds of array algorithms. But that's it for this video, and I'll see you in the next lesson.